start the recording. I'm going to start out by saying that whenever I assigned the homework last week, I assigned it as, is that word? Can y'all read it? Geometry? Okay. I assigned it as page 124, but several of you noticed that it actually started on page 122, right? So the homework starts on page 122. I scanned those and emailed them out. I think it was Friday. So everybody, even if you don't have a book yet, you should have access to it. And everybody hopefully has it. Yes, questions? All right, so I believe, let me think about this. Your syllabus quiz and your page 124, I think those are due today. Is that right? And then, Are
you talking about the lesson starting on 122 or the actual questions?
The actual homework questions. We're on one page.
I think that starts on 120.
It might be a difference. I'm gonna say this. There's a weird reprint that's out there. So some of the books have some just slightly off on the pages, like by 2 pages. So as I assign things, I realize like in my, I apparently have a second book somewhere, and
in mind the questions are
124, yeah. So one print, and I don't know if it's probably like one was printed in 2010 and one was printed in 2011 or something like that. But one print will be like read page 66 through 68. But whenever I go back on my new version, it says 64 through 66. So it's just slightly off. So as I assign things, if it's just a little weird, you know, you can ask me or be like, okay, mine did start on page 124, then you're good, no problem. But some people's version, it actually started on page 122, and that's the one I sent the other day, but they should still be the same questions. So if weird things happen, just let me know and we'll look at them, but y'all are good. Okay. All right, sounds great to me. Okay, I think that we had just finished up on all the different triangle congruencies on Thursday before we left for our Labor Day weekend. Yay, everybody, I hope it's fine, got back safely. So then I had said there's this thing out there that's called corresponding parts of congruent triangles are congruent. And that's what we're starting to look at now. The corresponding parts of congruent triangles are congruent. So there's actually kind of 2 phases. One is show that the 2 triangles are congruent, and then once you show that they are congruent, then you know that all their little pieces line up. You're fine. Okay. So I actually have some weird, I have a lot of problems for us to work today. So I want us to just kind of look and say, can we do anything with this? Yes or no? And I've got a lot of pictures, and unfortunately I'm not an artist. I've told y'all that before. So let me get my chat up. Christina cannot hear. Can anybody else hear me? Okay, Mary says I can hear. Okay, no problem. I just want to make sure I didn't leave you behind, Christina. All right, good. Everybody else is good. Okay, sorry, I didn't have the chat up. There we go. We're golden now. All right, so we've got a picture. It kind of, to me, looks like a bow tie, but a little bit slanty. It's labeled at the top T, at the bottom left G, in the middle is I, A at the top, and N at the bottom. I don't know what that one's supposed to be. Tange, Tanig. Usually these have words in them, so I don't see it. All right, and here are we have some congruency things going on. 1 here, 2 at the top, 3 at the bottom. 1 on the side AN, 2 at the bottom, 3 at the top. Okay, so the first question is, are these congruent? I'll let you think about it for a second, because then the second question is, how do you know? Okay, So everybody kind of play with that for just a second and see if you can figure out, are they congruent? They could be no, so. Samantha's got a lag, I'm sorry. Probably internet between here and,
Does the top of the page say corresponding parts of congruent triangles are congruent? Is that what it says?
yes, that is what it says.
Thank you.
Always let me know if you can't read my hand scratch. All right, what do we think? Are they congruent? Got a yes, I've took 2 yeses, 3 yeses. Okay, so we think yes. Okay, and if that is so, then we should be able to say why. Okay, you want to use SAS. I like SAS. Can you tell me what A you have?
The vertical angles for where the two triangles are connected.
Right in here. Okay, now notice that those weren't given, right? There was no congruency marked on that. But she knows, look, these are vertical angles. They're across from each other, so they have to be congruent to each other, right? So then what? Then so she said SAS. So she's telling me, for instance, which side would you like to pick?
And
Okay, NI right here has 2 hash marks. So that piece of that triangle is congruent to what? TI. Does everybody agree? Because that's the other one. So they don't have to be exactly side by side and they look the same. Think about this triangle over here. If I rotated it around rotated it around about 180 degrees, it would fall on top of this guy. So this double hash mark would be right on top of that double hash mark if I picked it up and turned it. Okay, so that's kind of the idea. You have to think about that. It's not necessarily exactly this triangle next to this triangle all the time. Okay, so there's a side she has. So I'm going to do triangle NIA because we started picking on NI. It's congruent to triangle, and because she did it like that, the N corresponds to which guy over here? The T. So the other triangle better be triangle TI, and this A here that's at the intersection of 1 hash mark and 3 hash marks, that corresponds, it's in the same position as this G, because the G is at the intersection of 1 hash mark and 3 hash marks. You see that? TIG. TIG. All right, so that tells me which order they go on. Now, she saw that angle. It wasn't given to her, so she pulled it, and I love that one. Is there another congruency? We could have used, Mary says side, 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 and she is exactly right. So let's throw in some side, side, side. And let's name them differently, just because I want to be a pain. Okay, so I'm going to start with GI this time. Okay, triangle GI. If I do GI, then the other piece would be T, right? It's congruent to triangle. Now, very carefully think about it. If I started with GI, remember I have to list them in corresponding order, right? So this G, who does he correspond with? A. So I have to start this triangle with A now. Okay. And I went from G to I, so I need to go from A to I. And the last guy here was T. He was out here at the intersection of 1 hash mark and 2 hash marks. So N is the last guy there. N. kind of like inked, but not quite. Okay. Now, notice here, this is triangle TIG, here, this is triangle GIT. Does it matter? No, it never matters as long as I put them in the same order, right? The corresponding parts with the other triangle. So you can pick it however you want to pick it, that's fine, but then follow through with the second triangle, make sure it lines up. Okay, so this is using a couple of our correspondence congruency conjectures. That's the word I'm after. Too many C words in this class. Is everybody okay with that one? Yes, ma'am.
We're using either side angle, side or side, side to side. Would we just list it exactly how you did there with that being before what is congruent? Because it does have to be listed.
Yes. Yeah, I don't care how you list it. You could have said, yes, this one's congruent to this one up there. I don't care. But yes, then you would have to tell me which one you're using. Okay.
I know this because so side angle side.
Yeah, you can just say side angle side. Yeah. So SAS, that's fine. So what you're going to see is as we progress in another week or two, we're going to be at proofs. And then we're going to say, okay, we know this, and here's our reason why. It's going to be your statement. Okay, state what you think. Okay, I think these two triangles are congruent. And then your reason. Okay, my reason is side angle side. Yeah, absolutely. Sounds good. All right, here's another one. Think to yourself. See if you can figure it out. It'll be awesome. We have a triangle. I have no clue what this is supposed to say. Oh, it's a boy. B-O-Y. I was reading yob. Boy. And they give me angle B and angle Y. And then the congruency on the line that's between them, BY. And then, I see. Okay, this one's triangle man. M-A-O-A-N. And the congruency is 1 here, 2 there, and 2 there. And what they want to know is triangle man is congruent to triangle what? Method says BYO, Jessica thinks BYO. Got some weird looks here in Commerce. People who are scratching their heads and turning their pages. Okay, I think what we're trying to do is we're trying to line up the fact that MA is the 2 hash mark guy, right? Okay, so we've got that one listed as MA, that came first. So what I'm hearing from Samantha and Jessica and Mary saying, can we use angle side? So hold that thought. What I'm hearing is if we use MA, then we have to use BY first. Does everybody agree with that? Because that's the side that lines up. And so we're like, can we do that? Now the problem then becomes, I need to follow them from piece to piece and make sure that everything falls exactly the same. when I do that, the first angle was the 1 hash mark, it's the M, okay? That definitely does line up with the B. It's 1 hash mark on that angle, okay? I'm good with that. But the problem is what? What's going on in the man triangle? Oh, Mary says, never mind. I think she sees there's a problem. The problem is what? In the man triangle,
Angle N?
what is it, Alexis?
Is it because if you do B, Y, O, angle O doesn't have isn't congruent to angle N?
That is exactly the problem, yes. So if I want it to go in the same order, okay, then for instance, man goes from the 1 hash mark on the angle to the 2 on the side, yes, thank you. And then nothing on this side, and then I'd go to the 2 hash marks, right? But if I follow that the same way, then it's 1, 2, and look, angle Y has 2 hash marks on it. If that was true, then A would also have 2 hash marks on it. Do you see that? It would line up right there. This guy is next in line, and this guy is next in line. So here I have literally angle, side, angle. They're all smashed together, right? The angle and the side is included between the 2 angles, okay? But the problem that Mary saw was over here, it's angle and then side, right? So they're not in the same order, okay? So unfortunately, unless I can line up and say the Y and the A are also congruent, we don't really care about the N, right? He could be congruent as well. But unless the Y and the A are both congruent together, then my notations aren't in the right spot. The same, Mary says the side and the angle does not line up, exactly. They're not there. So unfortunately, and this comes up a lot in your homework, you'll see this, we don't know, right? They didn't give me enough markings for me to figure it out. So I need Y and A to be congruent, and they're not. Instead, I've got Y to N, right? So that's a problem. So this is, we can't say that, sorry guys. I know we were trying to get the letters in the right order, right? But we can't say that. Instead, we're gonna have to say cannot be determined. And if you wanted to say a reason why it can't be determined, you could say like exactly what Mary just said, parts don't line up. Congruent parts don't line up. Something like that to make sure. If you come back in at the end of the semester to study for the final and you see that, then you go, why can't it be determined, you know? Then you'll go, oh yeah, that's right, those parts don't all line up together. That makes sense. Good job. All right. Let's do another one. These are so much fun. I love these. All right, this guy, I don't know why the book does this, is red. The RE has 1 hash mark, the ED has 2, and then the D has a congruent angle. And then the other one is bull, B-U-L, and has the BU has 1, the UL has 2, and the L has 1.
Or blue without the E.
Oh, or it could be blue, red and blue. I read Red Bull. Drink. You were correct. All right, so triangle red is congruent to. Think about it. And sometimes the book will actually lead you. It'll say triangle red is congruent to triangle what? So be very, 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 very careful on this one. It suspiciously looks like it should be congruent to triangle pool, right? It should be because they have exactly the same markings. So don't get carried away though, don't go crazy. So you go, oh, they have the same markings, 1, 2, 3, 1, 2, 3. They are in the same position, so we think, oh, they're congruent. But I'm hearing over here, they're not congruent. I'm seeing some shaking of heads. Why not? Oh, that's a bad word, right? This is side-side angle. Remember, follow it around. We have a side, followed by a side, followed by an angle. Make sure you do it in order, right? So that you can see it. Side, side, angle. You could go angle, side, side, but that's a really bad word. Okay, what do we know about side, side angle, Miss Summer?
It's not a triangle congruent.
Good.
Or a similar triangle.
Not even similar. Good. So this one doesn't work either. Stinking thing. This is not going to work for me, okay? So again, it would be cannot be determined, or we don't have one, there's nothing there, whatever you want to say. So let me know. The book's general answer is cannot be determined. Yeah, so even though it looks really pretty, don't just jump on it. Make sure that you go back to your list and make sure you know. The two bad ones are side, side, angle, because that's not a triangle congruence at all. And angle, 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 that only gives me similar triangles. It doesn't give me congruent triangles. All right. Well, let's change the mode, the look of it. Okay, here you go. Try this one. It looks like two triangles are kind of intertwined here. At the bottom, it's M-A-R. And then at the top here, I've got N-E-Y. I guess that's Marnie. I don't know. Okay. And instead of them saying, are they congruent, they give me a couple of statements. Okay, so I want to make sure we can read these statements and we all know what we're doing. Okay, so they say MN is congruent to MA. So if you would, take a second and mark your picture accordingly. I'll come back and do mine in a second. MN is congruent to MA. They also have ME is congruent to MR. So figure out a way to mark that one. And their question is angle E congruent to angle R? Okay, so first up, hopefully you're marking your thing. I've got MA and MN, so these are these little lengths right here. I'm going to put one hash mark on those. And then I've got ME and I've got MR. Which are those bigger lengths, right? Those are congruent. Does that help me any? What does that tell me? Why do they give those to me separately in a weird way? I need to kind of look at these as interlocking triangles if I can, right? It's a little weird, the picture. So if I can think of them kind of as interlocking triangles, I've got this one, M, A, E, right? I've got that triangle. And the other triangle that I'm trying to look at that I think is the interlocking one that they're comparing it to is what? Yeah, the little one here, the little length here, M, N, R. So it's weird the way they have it kind of interlinked. There's also this little triangle here and this little triangle here, but we don't really care about them. The reason why is because if you look, the base of MEA is MA, right? This little guy. And the base of MNR is this little guy. And that's the first one that they told me are congruent. Okay, so basically I know the bases of these two triangles are congruent. Okay, if you need to, and there's no shame in this, you can draw these out separately. You can separate them out. It's okay. Okay, you know, you would do like here's MAE, and here's MNR, and make them have their congruency just like that. It's fine. Okay, and then the reason I think that they gave me ME and MR is because they're using that as the long side here, not the hypotenuse side, but the longer side, okay, the longer leg on each of those. The ME and the MR as these upright guys. So again, if you need to kind of separate them and draw them, you can. But I think what they're giving me is two different sides on these two triangles are congruent. And then what else do I know because of the weird way they drew the picture? They have an angle in common. It's M. Does everybody agree? What Miss Summer just said. Okay, so that means that they share this angle. And we know anything's always congruent to itself, right? Okay, it's got to have its own measure the same. So angle M is congruent to angle M. There's actually a word for that. It's called an identity. But if you separated them out, then you drew them like that, maybe it makes it a little easier for you to see it. You don't have to. If you're good looking in there and seeing that they share angle M, you're fine. Okay. So now what do I have? Side angle side, right? I've got this side, this angle, and this side. Or going the other way, this side, this angle, this side. Or you can see them here in the smaller picture. I know it's a tiny picture. Okay, but definitely we have side angle side. So these two are congruent. We got that piece. So what we want to know though, they're not asking me are they congruent. They're saying is angle E congruent to angle R? Yeah, this guy way up here, right? Need another color. There we go. And I heard yes. And then the follow-up to that in Webster world is why. Okay, and you guys already told me side angle side, so you're good. Okay, so those are the kinds of questions that kind of just come up in the homework. You'll see them over and over again. I want to throw out a couple of little properties of triangles because we're not quite finished with properties or with triangles. We're kind of wrapping them up before we do proofs and stuff, but just a couple of little properties. And then if we have time, maybe we'll do some more problems or something like that. Are we okay? Okay, there are a couple of weird properties we just haven't hit. And in fact, I think somebody gave me one the other day, but we weren't quite ready for it yet. It's okay. No worries at all. It's always a good thing. All right, so a couple of little properties. We already know that all three angles add up to 180 degrees, right? What about this? What about if I look at some triangle and I try not to make him a 90 degree, and I call this A, B, and C. And then let me say this angle is 70 degrees and this angle is 35 degrees. And we don't know the third angle. Well, we can find the third angle pretty easily, right? So, we just know 70 and 35. And as a matter of fact, tell me, okay, so first of all, I only labeled the sides of the triangle, A, B, and C. And we know that because I've used lowercase letters, right? Okay, so if I wanted to label this triangle the way we normally do with capital letters, where would the A go? Okay, so I have one vote for on the 35.
35.
On the 35. Why?
The opposite side.
Ah, good, good, good. So the angle should be across from the side that has the same name. Does everybody agree? It's very much like whenever you did a right triangle, whenever you were working on Pythagorean theorem in your past. Okay. The largest side is the hypotenuse in that case, and the C is opposite it, right? The C, little c is the hypotenuse, and the angle, big C, is across from that, which makes the A across from the little a and the B across from the little b. So using that idea, what about here? Where's the C? Capital C is the one that I don't have a measure for yet, right? That's that angle up there up above. And that means that the B is here across from the little b, okay? So that's just a naming convention so that everybody knows what's going on. But then we want to say, list these sides in order from smallest to largest. List the
This side has the largest angle.
A, B, C in order. Let me swap that. Let me say largest to smallest. I know. Sorry about that. Just because I don't want you to think it's always the way I just saw it was going to be. What is the third angle? What is it, 85? Nope,
75.
75? 75 degrees. That angle up there. Okay. So we know nothing about the sides at all. We only know angles. Well, how can I possibly ask you to put the sides in order?
The largest side. We'll go with the largest side.
Okay, so not only is it that the lettering lines up, right? The large C goes with the little c across from each other, but what we're gonna find is that the biggest angle, the largest angle, is always across from the longest side. Now that's a really powerful thing. Okay, the largest angle is always across from the longest side. So therefore, the largest side has to be the C. Does everybody agree? Okay, so that guy goes first, C. And then the middle guy, B, and then the smallest is the A, right? That's why I changed them, because I didn't want you to say A, B, C. So the largest always goes with the largest angle. And it works the other way around too. If you know the longest side, then you know which side should be the largest angle, okay? And actually sometimes that works out for us in like the triangle inequality and stuff like that. We can be like, oh, that's never gonna work because that's gotta be the biggest angle and that doesn't line up. So we can keep this in mind. That's awesome. All right. Largest angle, always across from the longest side. And the smallest angle, always across from the shortest side. Same thing. All right. And then we had this exterior angle property. Or conjecture, or whatever it is. So here's my lovely picture for this. $135 degrees out here. P at the top and R at the far right bottom in my triangle. Okay, so first let's talk about exterior angle. Okay, whenever we talk about an exterior angle, basically what it means, we have exterior angles on all three angles of my triangle. Or if you were working with a quadrilateral, a square, or something like that, they have exterior angles also. Okay, so basically I've got an exterior angle over here on this guy. Let's call him Q, I guess. The book didn't give me a letter. But I've got an exterior angle there, but I could just as easily have an exterior angle here. And I could just as easily have an exterior angle here. Now the trick is knowing we don't want the 180-degree guy, right? All of these form straight lines. They should form straight lines, right? I don't want that guy because he's boring. He's a straight line, right? Whenever I talk about the exterior angle, I'm talking about the one that's less than 180 degrees, right? So let's think about this. Let me redraw this for just a second. And I drew it here on angle Q. Let me draw it this way instead. Let's talk about that. This guy was 135 degrees. So some people get hung up a little bit. They're like, well, how do I know which one it is? Why didn't you draw your exterior angle the other way? And I totally could have, right? This is an exterior angle and this is an exterior angle. If I just drawn the 180 degrees the other direction. So what I think should happen is that exterior angle on the bottom side should actually be the same measure. So I need somebody to tell me why that would happen. I think I heard it.
Vertical angles.
Yes, those are vertical angles, right? Like this is just the intersection of two lines coming in like this. I've got 135 up here and I've got 135 down there. Those are vertical angles. We know they're congruent, right? We did that like first day. Vertical angles are congruent. Boom, done. Okay, so I know those are congruent. So therefore, it doesn't matter which way you draw your line. Does that make sense? I could have just as easily drawn it going down this way, and we could be talking about this 135. It doesn't matter. Because then this way would be 180 straight line, right? Okay, so we don't care which one. What we do care about is the relationship between this exterior angle and the other two guys. So it goes like this. An exterior angle is congruent to the sum of the opposite two angles in the triangle. Exterior angle is equal to the sum of the other two triangles in the triangle. So if that's true, then we think 135 degrees is equal to what? It's not equal to Q. What are the other two angles in the triangle? Yeah, P and R. So it should be the sum of P plus R. Does that make sense? Now, sometimes your book will do a shorthand. It'll do 135 equals P plus R. But the true geometric way to write this would be it's the measure of angle P plus the measure of angle R. Because we're talking about actually 135 degrees is a number, right? It's an actual measurement. So a lot of times in your book, you'll see them do that. It's the measure of the first angle plus the measure of the second angle. Angle P plus angle R. Yes, ma'am. Miss Jessica's got it. Perfect. Okay. Good, good, good. All right, so here's a picture. Y'all figure it out for me. It looks like, let's call this angle S. And down here, I've got 58 degrees. And on the outside here, I've got 130 degrees. And what I want to know is the measure of angle S equals what? I'll just use that property.
One, 58.
58 degrees, yes, ma'am.
Should we tell you what we got now, or we wait?
I'm sorry, say it again.
If you think you know the answer, can we tell you?
Yes, ma'am, tell me.
Is it 72?
I don't know. I have a vote for 72 degrees from Miss Alexis. I got a nod here, I got a nod here, I got 3 nods in commerce. So 3 people in commerce agree with you. So I'm gonna write it right there. How did y'all get there? Okay, we know 130 degrees has to be measure of angle S plus 58 degrees. Does everybody agree? And that was the given. That's what Ms. Summer is telling me. We were given that 58 degrees. Okay, and so then what I hear is because of that, if I want to get measure of angle S all by itself, I can just subtract 58 from both sides. And if y'all's mathematics is correct, because I'm not doing the arithmetic in my head, then what I'm hearing is that 72 degrees. Everybody agrees. Awesome. Okay, good job. Awesome, thanks Alexis. All right, so we've got an angle measurement here, and what you used was actually, interestingly enough, what y'all have started using is some angle sum stuff that we haven't even gotten to, but if you look through your postulates, that postulate list that I gave y'all last week, and the word bank and things like that, you'll start seeing some of these properties coming in. For instance, how did y'all know y'all could subtract off of 58 off of both sides of that equation? That's an algebra concept. You're applying algebra concepts to geometry work? Absolutely we can. Yes, yes. So y'all are doing great. So this is actually what you're using here. It was originally addition inside of an equation, right? This is an equation. You guys use the subtraction property of an equality, okay? Which just says, I'm going to subtract 58 off both sides, basically, right? That guy goes away, and then I had to figure out what that guy would be there. And so you're using the fact that, hey, this is an equation. I can solve it just like any old algebra equation, right? And so in your list, there are some properties, and some of them were properties of equalities. The subtraction property of equality is what you just used. Absolutely. Good deal. All right. Let's see another one. I really like these little puzzly things, by the way. Hint, hint. You might see some of these on a test. Hint, hint. By the way, when is our first test in here? Did y'all look at that yet? This is week 3. Labor Day. It's week 6, right? So we're halfway to the first exam, okay? I don't say that to scare you. I just say that to mean, okay, start. If you haven't been keeping up, then make sure you're doing everything. Oh, Samantha says October 5th. There we go. So it is first week of October. So 3 weeks, that's all I know. 3 weeks. I don't know that date. Thank you, Miss Samantha. All right, I've got parallel lines. I'm going to justify that they're parallel by putting little chevrons on them. 2 little chevrons. And what we've got is from this first top line, I'm going to drop straight down. It is a 90-degree angle. And then I'm going to come back up like that. And then on the other side of things, I'm going to have a line that comes down and makes a triangle out of the top there. I've got a little triangle up here. Big triangle here. It drops all the way through both parallel lines. All the way down. Goes all the way back up. And then at the very top, make sure you have a little small triangle above the top parallel lines. I know sometimes it's hard to reproduce these just by listening to what I say. There's a section in your book that's called a picture is worth 1,000 words. And that is true. I could describe this all day, but it's easier if you just see the picture and reproduce it, right? Which is why a lot of times in your test, it's easy just if you start with a picture. Start with a picture, that's awesome. Okay, I've got a right angle here, and then below the second in the smaller triangle down here, I've got angle A, and beside it is angle B, and the very lowest angle in this triangle is 22 degrees. Okay, so AB and 22 degrees way down here. And then just above angle B is angle C, this 1, 2, 3, 4 quadrilateral. The bottom right angle is angle C. And then I've got this middle quadrilateral. What does quadrilateral mean? 4 sides, okay, a polygon with 4 sides. So in this middle guy here, I've got D and G. And above D, I have E. And this very top angle is F. I'm sorry, I don't have much space there. And then way over here is H. I've got angles A, B, C, D, E, F, G, and H. And of course, they want me to find measurements for all of those. G and H. They give me one more little bitty piece of information, which is that this line here between E and F is congruent to this line here that's between angle D and G. So that little angle, or that little triangle there, let me zoom this a little bit. Oh, too close. Man, so good. All right. This little triangle here, I've got an isosceles triangle. Does everybody see it? This line and this line are congruent. Okay, so I'm going to give you just a second to work on it. I'm going to finish the roll sheet. You guys figure out as many of those angles as you can figure out. Start with A. I think it's the easiest. Maybe it's the easiest. So correct me if I'm wrong. I think I'm missing Gabriel. Gabriel wants 2 G's, I'm sorry. Caroline's not here, Demondra's not here, Summer M. She might have dropped out. I haven't seen her in a while. If y'all know her, find out. Elijah, Amberly, and Cameron. All right. Everybody else is here. Cool. Okie dokie. What do y'all got for me? Anything? Ashley, do you have something? I'm gonna pick on you.
So the easiest to find out is A, it's 90 degrees.
90 degrees. A is 90 degrees, she says. Why do you think that is true?
Because the angle that's, the corresponding angle that's above it is 90 degrees. Because wouldn't that line that you just drew over technically be a
Okay.
transversal?
Good. She's telling me that these are parallel lines and this line is a transversal. She is correct. And so she said this corresponding angle up here is 90 degrees. So A has to be 90 degrees. Does everybody agree? All right, I like it. All right, somebody else. Do we have angle B maybe? For you?
68 degrees.
68 degrees is what I'm hearing from Ryan. He jumped in on that one. He said, I know that one. Okay, and I'm assuming you got that by what?
If we know one angle is 90 and we need to know 90 minus 22.
Okay, good. So the entire triangle adds up to 180 degrees on the interior angles, right? He knows one is 90, so he subtracted 90. So then I only have 90 degrees left. Minus 22 gives him 68. Perfect. I like it. Uh-oh. Somebody else is writing me stuff. Mary said A is 90. Samantha says B is 68, so they agree. Oh, Mary gave me a whole bunch of them. So Mary, I'm gonna pick on you. She says C is 112 degrees. How do you know that, Miss Mary? Supplementary angles. Okay, so she's saying that this is a straight line. There we agree. And because that makes 180 degrees, supplementary angles add up to 180 degrees. Or we have another word for this in our vocabulary, linear pair, right? Okay, also means the same thing, means they add up to 180 degrees. So she took 180 and subtracted 68. Can we agree? All right. B and C are supplementary angles. Yes, ma'am. Miss Alexis, did you have something? You looked like you were about to say something.
I was gonna say that C was 112.
Oh, sorry, dang it. Do you have another one?
No, I mean, I found out that that angle across from B is 68, and then I was trying to see how you would get something else.
Okay, good. So she figured out this angle here that doesn't have anything in it is 68 degrees. I like that. What reason do you have, Miss Alexis?
Vertical,
Absolutely, vertical angles, good job. So B and this unnamed angle are 68 degrees, and she didn't necessarily have to get that, but sometimes you need to get an extra angle just to help you figure things out, right? Okay, so that may come in handy for us. I like it. Okay. So anybody? Yes, Maria, what you got?
D is 112. This is the alternate and no.
That's you.
Alternate what? Interior, yes. So look, we've got a set of parallel lines here. This is what she's telling me, right? We've got a set of parallel lines here. This line right here is a transversal. Everybody remember that. This goes back to like day one. Oh my gosh, we can't forget that stuff. So these are alternating because one's on the left side and one's on the right side, and they're interior between the two lines angles. So because they're parallel lines, she knows those are congruent. Everybody agree? I like it. And Miss Mary had already written that for me in the chat box, so she confirms it. I like it very much. Okay, what else do we have? I bet somebody can give me angle E now. I don't have enough space. I should have drawn my picture bigger. Dang it. What do we think about angle E? think it's also 68 degrees, okay? And I actually have a lot of reasons for that. So Maria, you said 68 first, I think. What do you think? Why? Okay, linear pair with D makes a straight line. And must add it to 180 degrees. Mary also said it was 68 degrees. Mary, do you have a different reason? Put her on the spot here. Sorry, Mary. Probably typing. Man, sorry. Put her on the spot. Okay. Anybody else have a different reason? Or why E must be 68 degrees? You only need one.
Is the corresponding equal of 68, the one that Alexis stated?
Mm-hmm. Yeah, it's the same as what we did between C and D, or I'm sorry, Ashley stated, right? Between here and A, these two guys are corresponding. So here I've got this guy, 60, yeah, I'm with you. Alexis gave me 68 degrees, and so this guy is in the same position. All right, good. So it's the same reason Ashley had, and it's the same angle as Alexis gave me. So they've got to be 68. We've got two reasons now, right? All right, what else? Whew. Now it's getting tough. E is 68 degrees. Yes, ma'am.
F is 56,
F is 56. Why do you think that?
because the triangle formed at the very top is isosceles, and because we know one angle, the other two angles have to be congruent because of the sides that they correspond with.
Okay, let me blow up this triangle for us. Okay, so it's a little bit small here. So we know E is 68 degrees, and there's always a reason why they give you that little extra piece of information, right? So Ms. Summer says, look, they told me this is isosceles, right? Okay, congruent on the transversals, angles B and E. Yes, ma'am. Samantha's got B and E together. I like it. Oh, shoot. That would be alternate exterior angles is that one, right? Yep, that works. So we have three reasons for 68 to be E to be 68 degrees. Okay, so Ms. Summer says, look, inside of this triangle, it's isosceles, and we know the base angles of an isosceles triangle are congruent, right? So she's got this guy and the unnamed guy as congruent. All right, so because of that, what did you do?
180 minus 68 minus 2x.
Okay,
It's
so
another variable.
okay, find some number or whatever to call it, right? Okay, so 180 minus the 68, because that's what E was, and that gives me 112 degrees. Are we okay with that? And then she said, but look, that's the total here. I know they're congruent, so I can divide by 2. Okay, divide by 2, I get 56 degrees. Is that what you said? And the unnamed guy is also 56 degrees. We just didn't ask for him. Does everybody see what she did there? So we know way up here, let me come back here, this little guy here, F is 56 degrees. Okay. And we also know this guy's 56. We might need him. Why would we need him?
To find out G.
Yeah, because we need G, right? So maybe that might help me figure out, oh, what is that guy? So 180 minus 56 will give me G?
24.
124? All right, I like it. All right. Let me back this out so we can see now. Now that we're in the bigger part, I think we'll be out. Okay. Focus, thank you. All right, so that's what we got so far. Y'all have done a lot of work to get here. I love these things. They're like puzzles to me. I think they're fun. Y'all don't like them? I like them. I think they're fun. So you're gonna see some on the test.
I like drawing them.
You like drawing them?
I know,
Oh,
I
you
don't
don't like
drawing
them.
them because I always make
Oh, me too, yeah. So on a test, they would be pre-drawn on the test for you, so that's good. So then you just be using your properties to figure out what's what. Yeah, you're not gonna have to redraw for me. All right, now I've got angle H out there, and he's a bit of a problem. He is an exterior angle, right? But we can't use that triangle guy that we just had, because this isn't a triangle, right? So he's an exterior angle, but he's an exterior angle to this quadrilateral. So I need to figure out this extra unnamed angle of the quadrilateral. So did anybody work on the glossary that I handed out at the beginning of the semester? Yeah, it was, you didn't have to do it, but it was for making sure you knew some stuff. There was a little bit of a bonus at the end. Maria, did you look at it?
No.
No.
I think we're heading in different directions, but it's also the, because you have the two parallel lines and the transversal, it's the alternate interior.
That's so much easier than what I'm gonna do. Let's get it, and then we'll talk about what I'm gonna talk about, okay? So, good job. She sees, look, you don't have to do all that, Dr. Webster, you're crazy. These are parallel lines. This is a transversal. Which guy would you like to go off of?
G,
G is
the alternate interior.
alternate interior with H. So that means what? Brian says, yes, that's so much easier.
They're equal. The measurements are equal.
Those two must be congruent. Good. Their measurements are equal. So that one's 124. Yay, we're done. But you're not done yet, because I'm going to still get you my thought process in there. So clearly that's way easier than what I'm about to do. But I want to talk about quadrilaterals real quickly. We have a sum, everybody knows it, 180 degrees for triangle sum, right? Interior angles of a triangle. But at the end of that little quadrilateral, there you go. Everybody breathe a big, you did it. Big sigh of relief. That was a good one. I like that one. That was fun. Just be prepared on the test, because I like one. All right. So you had something that said, hey, look, interior angles of a triangle add up to 180 degrees. Oh my goodness. Okay. But then it also said what? Interior angles of a quadrilateral add up to, oh, and y'all found that it was 360 degrees. Some of you actually played with it and saw. And then it was interior angles of a pentagon. It's 540 degrees. And you found that one all by yourselves? Did it ask for your hexagons?
Yes.
Okay. Interior angles of hexagons, 720 degrees. There ought to be a pattern in there somewhere. Add 180, I heard it. Good. Plus 180 degrees, plus 180 degrees, plus 180 degrees, right? So every time I add a side to the polygon that I'm drawing, it adds 180 degrees into the interior angles. That's a lot, okay? From the triangle to the quadrilateral, it doubles, okay? We can actually see it really easily from the triangle to the quadrilateral, because we can go like here and then see like that, right? We can see, oh, this is a triangle, it has 180. This is a triangle, it has 180. So there must be 360 degrees in there. Okay. So it's easy to see for the quadrilateral, but not so easy to see as we get into bigger guys like pentagons and hexagons and stuff like that. So we asked you, I think I asked you to come up with a formula. Did we do it? Okay. Whenever I look at a triangle, I get one 180. When I look at a quadrilateral, I get two 180s. So there's this little thing that happens. The number of sides of the polygon, 3 sides, 4 sides, 5 sides, 6 sides, and the number of degrees. And I'm going to cheat, and I'm going to say 2 groups of 180. This is 3 groups of 180. And this is 4 groups of 180. Everybody see how that's working? We just kept on adding a 180 every time. So this leads us to this really cool formula that we can use anytime we're dealing with the interior angles of a polygon at all. So how is, this was 1 group of 180. How is the 3 related to the 1? Or the 1 related to the 3? How is the 2 related to the 4? Difference of 2, difference of 2. 5 related to the 3, difference of 2. 6 related to the 4, difference of 2. So what we see is if we call this number of sides n, then n minus 2, 3 minus 2 gives me 1, 4 minus 2 gives me 2, 5 minus 2 gives me 3, 6 minus 2 gives me 4. So just kind of check whenever you get some of these weird formulas that they actually hold up as I build, that they really will generalize. But there's a cool little formula, right? Okay. So where n is the number of sides on a polygon. Okay. So that, I think I handed that out like first day of class, maybe second day of class. I gave y'all those glossaries and said, make sure you can do this stuff, right? And then I just kind of left you to it. And I said, we'll come back to it. We'll make sure everybody sees it. So if I think about that, and I've got this formula in my back pocket that I can pull out anytime I'm looking for polygons, okay, side angles in a polygon, that kind of thing, then what I'm going to do is I'm going to come back here and I'm going to use it, okay? This is a quadrilateral. This guy must have 360 degrees in its interior angles. That's what I'm telling you, okay? So let me cheat a little bit and say, well, that quadrilateral's got to add up to 360. And I already have 112 in there, so let me do my arithmetic real fast. Check my arithmetic always. And I already have 124 in there. Hmm?
You also have 68 in the one.
Oh, and I already have 68 in there. I'm like, this isn't adding up. Not adding up. Okay, so thank you. I've got to count my angles, right? Is that a 5? 56. Okay, so what does that tell me about this guy? This is my 4th angle in the quad. Okay. Here we go. Boom. Everybody see that arithmetic? I know, always check my arithmetic. This guy's got to be 56 degrees. And then what that means is this guy is 180 straight line. So we can subtract and get 124, which works. Okay, now clearly my way is a lot more work than your way was. I just wasn't paying attention to parallel lines, which I should have been. Okay, we all can do those things. The important thing is, and we saw this with a couple of things like this 68 degrees up here. It doesn't matter what your reasoning is as long as your reasoning is sound and you do the math correctly, right? So you could have gotten to 68 like 3 or 4 different ways. We should solve them. I don't care, and as long as you just give me a reason and it's correct, okay? And your reason can be different from her reason, and that's okay. And when I'm grading that kind of stuff in a homework or on a test or something like that, it's all right. I'll just go, oh yeah, yeah. Even if it's not what I have in my key, I'll sit there and go, oh, okay, yeah, they're good. You know, so it's all right. You don't even have to think the same as I think, as long as your math is good and I can see your reason. All right? That is fun. I love those. Make sure you can do them. Yes, ma'am.
You had given us lesson 4.4 to 4.6, but we haven't done anything on that. Do we still just hang on to that?
It is due now. We have done the coordinating parts of congruent triangles are congruent. That's what I was holding out on. So you will now have 4.4 through 4.6. That's a handout. Due in 1 week, Tuesday. That's September 15th, right? There you go. It's like I paid her to ask me that question. So we have now done all that stuff, so you can now work on it. It's already loaded into D2L, so you should have already hopefully seen it under week 2. I'll make sure it's loaded up for this week 2. you have questions, hang around. Otherwise, I'm out of time. Perfect timing today. Let me know if you have questions. We're filming on Zoom. See you guys.